morning, everyone. This is your teacher, Sir Teddy. Welcome to our science class. Today, I will discuss to you series circuit. Okay, kids, get ready because in just a moment we will discuss the lesson. Sit back on your comfortable place. Energy has many forms. One of these is electricity. Electrical energy is one of the energies that most valuable to us. It makes life more comfortable and convenient for all of us. At night, we can see and do things thanks to electricity. For our appliances to work and for our homes to be lighted, electricity must travel in a circuit. So what is a circuit? A circuit is a path in which electrons can move. The word electricity is derived from the Greek word electron, which means ampere. Electricity is thought to have been discovered in the ancient Greece when someone rubbed a piece of amber and it picked up light materials such as feathers and hair. Of course, this is possible due to the fact that friction can generate electricity. Static and current electricity are the two kinds of electricity. Static electricity is produced when electrical charges build up on a surface of a material, usually as a result of friction or rubbing materials together. This electricity produced by the continuous flow of electrons is known as current electricity. Alessandro Volta, an Italian scientist, discovered current electricity. It is made up of moving electrons that flows through electrical wires connected to lights, machines, and appliances to make these devices work. Current electricity is the kind of electricity that we often use in many activities. It flows through a complete circuits. An electric circuit is a network that has a closed loop giving a return path for the current. There are two types of circuits, namely series circuit and parallel circuit. Okay kids, as we go on with our discussion on series and parallel circuits, let us first go over some basic terms that we need to familiarize with. Number 1. Current. The flow of electrons. Electricity has works to do, and when the electrons are flowing around a circuit, that currents at work. Number 2. Circuit. A closed continuous path for electricity to flow, composed of power source, connecting wires, load, and switch. Number 3. Resistance. The restriction or opposition to the flow of electric current. This is what electricity encounters when it flows along with physical materials. Number 4. Voltage. It is the measure of work required to move a unit charge from one location to another against the force which tries to keep electric charges balanced. In the context of electrical power sources, voltage is the amount of potential energy available per unit charge to move charges through a conductor. Parts of an electric circuit. A circuit has parts or components. These are the conductor, the source, and the load. The conductor serves as the pathway for the electrical current to pass from the source to the different parts or components in the circuit. Example, connecting wires. Number 2. The source contains positive and negative electrons. It is the source of electrical energy in the circuit. Example, dry cell or battery. Number 3, the load determines if the electricity that flows in the circuit is close or complete. Example, bulb. There are three kinds of electric circuits based on the connection. Number 1, series circuit. Number 2, parallel circuits. And number 3, combination circuits. Kids, we will focus on the first two circuits. A series circuit is a circuit that allows electric current to flow through a single path. The available electric current flows through its load, but there is only one complete path. If one bulb is loose or does not work, the circuit is open and the current does not flow. The rest of the bulb will not light. The defective bulb has to be replaced, or the loose bulb should be screwed tight for the current to flow again. Remember that the current is the rate at which electric charge flows past a point in a circuit. For the devices in a series circuit to work, each device must work. If one goes out, they all go out. Changing the number or type of components in a series circuit has an impact on the circuit's overall performance. When it comes to how current and resistance operate in a series circuit, there is a universal rule to remember. The more work a series circuit does, the more its current will decrease. As you add more resistance to a circuit, like a few bulbs or even resistors, at that point, the more work for your power source or battery. Let's say take the circuits presented above that had two lights bulb. What do you think would happen in the event that you add another light bulb to this circuit? Will the bulb shine as bright? No. Once you plug in the third bulb, all lights bulb will get equally dim since you have added more resistance to your circuit, which decreases the flow of currents. Adding a light bulb in the arrangement decreases the current since our battery now has more work to do. Advantages and disadvantages of series circuit. Advantages: more power source can be added to increase the voltage. Number 2, does not require lots of wiring connections. Disadvantages: only one pathway for an electric current to flow through. Number 2, when one bulb burns out, the other bulb will not function anymore. Number 3, increasing the number of loads, decreasing the current that passes through its bulb. Okay kids, that ends our lesson for today. Continue answering the different activities on your module. See you again on the next video lesson.